You know, large language models can feel like they're pure magic, right? But behind the curtain, there's this really rigorous process of training and optimization. So today, we're going to pull that curtain back and see exactly how these incredible tools are built and fine-tuned. All right, so here's our game plan. We're going to start with the big picture roadmap. Then we'll dive into how to use models that are already trained, how to tune them like a high-performance engine, and how to dodge common pitfalls like overfitting. And finally, we'll see how it all comes together for real-world tasks. First up, the LLM training roadmap. Look, building an LLM isn't some chaotic sprint to the finish line. It's much more like a carefully planned journey. And this roadmap? This is our guide, taking us from that first spark of an idea all the way to a fully deployed model.
But that's the big question, isn't it? You've got this awesome idea, but taking that first step can feel, well, massive. So where do you actually start?
And you know what? The answer is actually pretty straightforward. It all kicks off with a really clear objective. What problem are you trying to solve? That one question, that initial mission, it guides every single decision you make from here on out. So here it is, the complete 10-step roadmap. I like to think of it in 3 main phases. First, you've got the setup phase. That's where you define your objective, gather your data, and pick a model. Then you enter the core loop. This is the cycle of training, evaluating, and tuning over and over. And finally, you have the deployment phase, where you get your model out into the world and keep an eye on it to make sure it's still doing its job well. But here's the thing. You don't always have to build that entire model from the ground up. Which brings us to leveraging pre-trained models. I mean, why reinvent the wheel when you can stand on the shoulders of giants, right? So that leads to a really practical question. Let's say you have a powerful general model, something like a BERT or GPT. How do you take it from being a jack of all trades and turn it into a master of one specific thing you need it to do? The secret sauce here is a concept called transfer learning. Think about it like this. You're not teaching a total beginner from scratch. You're taking an expert who already understands language deeply, and you're just teaching them a new specialty. You get to leverage all that existing knowledge, which makes the whole process way faster and way more efficient.
And there are a few key ways to do this. Fine-tuning is probably the most common. It's like making tiny, precise adjustments to an engine that's already really good. Then there's multitask learning, which is where you teach the model a few related skills at the same time. And domain adaptation. That's like giving your model a specialized dictionary, so it becomes fluent in the lingo of a specific field, like medicine or law.
Okay, so our model is specialized. Now it's time to tune it for peak performance. This is where we really get under the hood and start turning the dials to make sure the model is learning as effectively as it possibly can. Now, for anyone out there who's worked with relational databases, you know that proper indexing is absolutely critical for performance, right? It's a foundational step. So, what's the equivalent of that for a large language model? The answer is hyperparameter tuning. These are basically the knobs and dials you get to adjust before you even start training. The learning rate, for example, is all about how fast the model learns. If it's too fast, it'll miss important details. Too slow, and training takes forever. The batch size affects how much data the model looks at in one go, which impacts both speed and stability. And regularization is super important. It's a technique that helps stop the model from just, well, memorizing the training data. And beyond those core settings, we've got other smart techniques too. Early stopping is kind of like a safety switch. It just stops the training if it sees the model's performance starting to dip. Warm-up is like easing a car into gear instead of slamming on the gas. And gradient clipping, think of that as a guardrail, keeping the learning process from going off the rails. All right, let's tackle one of the biggest challenges you'll face when training any model, preventing something called overfitting. This is all about making sure your model is genuinely smart and not just a really good memorizer.
So here's the million-dollar question. How do you build a model that can take what it's learned and apply it to new things it's never seen before, instead of one that just parrots back the answers it saw during training?
Well, this problem is called overfitting. It's when the model gets so good at the specific training data that it completely fails when it sees anything even slightly different. It's like a student who memorizes every question on the practice test, but then can't solve a single new problem on the actual exam. The good news is we have a whole toolkit to fight this. Techniques like dropout work by randomly switching off parts of the model during training. This forces the other parts to become stronger and not rely on any one single piece of information. And then you've got stuff like adversarial training, which is more aggressive. You intentionally show the model tricky examples to build up its resilience. It's kind of like a vaccine for your AI.
And now we get to the fun part. We get to put all this theory into practice. This last section on fine-tuning is where everything we've talked about, the pre-trained model, the tuning, the anti-overfitting tricks, it all comes together to build something really useful.
Let's start with a classic example, sentiment analysis. The goal is pretty simple here. Teach a model to read something, like a customer review, and figure out if it's positive, negative, or just neutral.
So here's the workflow. And does it look familiar? It should. It pretty much mirrors that big roadmap we talked about earlier. You pick a model, but the really crucial part is the data. You feed it thousands of examples that are already labeled positive, negative, or neutral. And the fine-tuning process then teaches the model to become an expert at spotting that sentiment. Okay, for our second use case, let's look at named entity recognition, or NER for short. This is all about teaching the model to scan a sentence and pull out specific things, like people's names, locations, organizations, you name it. Now, here's the really cool part. Look at the pattern here. The process is almost identical, and that's the key takeaway. The only thing that's really changing is the data we're feeding it. Instead of sentiment labels, we're tagging words as person or location. This just goes to show how flexible this whole framework is. You can use one powerful model to solve dozens of different problems.
Hey, if you found this breakdown helpful, do me a favor and hit that like button, share it, and subscribe. It really helps us make more explainers just like this one.
And that's a wrap. We've gone all the way from a high-level idea down to a practical, deployed model. So I'll leave you with one final thought to chew on. With all of these powerful tools at your fingertips, what is the one problem you would train a large language model to solve? Thanks for watching.